Hello, in this video we will learn about uniform circular motion. If a particle moves along a circular path with a constant speed, that means it covers equal distances along the circumference of the circle in equal intervals of time, then its motion is said to be a uniform circular motion. Examples: motion of the tip of the second hand of a clock, motion of a point on the rim of a wheel rotating uniformly, and there are so many examples which you experience in your daily life. Here, in this section, we will mainly consider the uniform circular motion with constant speed. And if the speed of the motion is constant for a particle moving in a circular motion, still the particles accelerates because of constantly changing direction of velocity. Angular displacement. The angular displacement of a particle moving along a circular path is the angle swept out by its radius vector in the given interval. As shown in figure, when the particle moves from P to P dash in time delta t, the line OP vector, known as radius vector, moves through an angle delta theta. This delta theta is called angular displacement because when the particle is moving along the circumference of the circle, then there will be a change in the angle made by the radius vector at the center, and this change in angle for that particular time will be the angular displacement. Also, you can see that the velocity vector v turns through the same angle delta theta and becomes v dash. The linear displacement along the circumference pp dash is delta r, and the linear distance delta s is the arc pp dash. Now here comes the angular velocity. Angular velocity is the rate of change of angular displacement. It is denoted by omega and is measured in radian per second. And the dimensional formula for angular velocity will be m0 L0 t minus 1. As shown in the diagram, the distance along the circumference from A to B is r into theta. Here theta is the angle made, where r is the radius of the circle. So magnitude of the velocity will be ds by dt, means r d theta upon dt. Because radius of the circle will remain constant, so omega is equals to d theta by dt, means it is the change in the angular displacement with respect to time. And In the terms of delta theta, vector omega will be equals to limit delta t tends to 0 for very short duration delta theta upon delta t. Time period. The time taken by a particle to complete one revolution along its circular path is called its time period of revolution. It is denoted by capital T and is measured in seconds. So time period of the motion, when it will complete one circular motion, that means the total angle will be the 360 degree or 2 pi radians. So the time period will be equals to 2 pi divided by angular velocity. Next one is angular acceleration. Angular acceleration is the time rate of change of angular velocity of a particle. If delta omega is the change in the angular velocity in delta t time, then angular acceleration denoted by alpha will be equals to d omega upon dt. And by putting the value of d omega, you got d square theta upon dt square. Means it is the second derivative of the angular displacement with respect to time. If you differentiate it for one time, you will get d theta upon dt. That will be the angular velocity. And if you will again differentiate it, then you will get d square theta by dt square. Take care, it is not d theta by dt whole square. You have to represent as d square theta by dt square. It represents the second differentiation of angular displacement with respect to time. And the unit will be radian per second square and the dimension will be m0 L0 t minus 2. Now, relation between linear velocity and angular velocity. The linear velocity, you know that it is the rate of change of linear displacement. Means V will be equals to delta S by delta T, limit delta T tends to 0. And you know that the linear displacement delta S is equals to R into delta theta. So by putting this value, you got V is equals to R omega in terms of magnitudes. But if we have to represent it vectorically, then it will be vector V is equals to omega cross R, and it is known as the cross product, which we will study in the chapter rotational motion. Now let's find the relation between linear and angular acceleration. As V is equals to R omega, differentiating both sides with respect to time, we get dv by dt equals to differentiation of r omega with respect to dt, or dv by dt equals to r into d omega by dt. As r is constant and d omega by dt is alpha and dv by dt is a, so you got a is equals to r alpha. And in terms of vector notation, vector a will be equals to vector alpha into vector r. Or you can say that the linear acceleration is the cross product of the angular acceleration and the radius vector. And the direction we can find out by using the right hand thumb rule, which we will study in detail in the rotation motion. Thank you.